Welcome to our webinar today. This is the third of the Rescale Solutions live webinar series. So we're featuring hands-on demos in science and engineering applications on Rescale. So my name is Jolie and I'm with Rescale and I will be the moderator today for this webinar. And today's focus is on how to run end-to-end CFD workflows on Rescale using ANSYS. So the next webinar, we also wanted to make you aware, change my screen here. The next webinar in this series will take place 2 weeks from today. We tend to do them about every 2 weeks, and that will be on Wednesday, June 17th, and we'll cover scaling up simulations of internal combustion engines by the way of converged CFD. And then on July 1st, which will be 2 weeks after that, we'll show how to fast-track CFD design in space exploration. So a few different topics here, and you're welcome to join us for all of those. Okay, without further ado, let's go ahead and get started. As we proceed, also, I wanted to make you aware, if you have any questions, feel free to write those in the question window that you see as part of GoToWebinar's platform. And we will keep an eye on those questions and we'll try to answer them as we go, but at the very least, we'll make sure that we have those questions answered at the end of the webinar. So feel free to write those in. We have one speaker, one presenter lined up for today. His name is Clinton Smith. So Clinton Smith, a little bit about him. He is passionate about working with people to solve problems using cloud computing, and he loves inspiring people to do the same. With a PhD in mechanical engineering, Clinton has a 13-year background applying CFD and thermal experience in a variety of industries. He works as a solutions architect at Rescale, where he gets to help customers realize their objectives with cloud computing. We're happy to have Clinton here. So at this time, Clinton, I will go ahead and turn webinar control over to you.
Fantastic. All right, well, thank you for the introduction, Jolie. My name is Clinton Smith. I'm a solutions architect based out of Phoenix, Arizona. And I'm happy to present to you today end-to-end CFD workflows on Rescale. And we'll start kind of with a high level where we'll look at the question, why Rescale in the first place? There's some specific sort of top level answers to that. One of the big ones is it's a complete HPC solution in the cloud, but there's more specific ones as well. And these tend to be maybe more particular for one type of workflow or customer to another, but some common themes we'll touch on, like time to solution, faster time to market, robust designs. And we'll also talk about, on the technical side, some answers to that question, why Rescale. Access to different types of hardware to fit your workload are one. And then we'll also touch on a special use case for multi-physics, where maybe you have a fluid structure interaction or conjugate heat transfer workflow that you want to take to the cloud on Rescale. We'll touch on that as well. We'll spend most of our time today on live demo of a set of use cases here. We'll start with a batch solve with ANSYS Fluent, and then we'll take sort of the example use cases sort of on the beginning and the end of a batch solve. So maybe we want to actually do our mesh generation on the cloud with Rescale. So we'll touch on that. I'll also show you how to extract results through a live UI post-processing session on a Rescale desktop. And then we have a really nice product called End-to-end Desktops that is made very specifically as a great fit to address the multi-physics use case that I mentioned as well. And then last but certainly not the least, I want to show you the administrative point of view of the Rescale platform, as well as bringing your own licenses and connecting them up to run your simulations with Fluent in the cloud. And at the end, we're going to focus on all these demos. We'll use an exhaust system model. It's a fairly good size industrial scale case. But we've also done benchmarking with this case. And so I want to show you those results as well toward the end of the webinar. And definitely please ask questions or post them in the questions bar in the webinar. I'll pause at a few points to see if there's any relevant questions for the different sections that we'll cover. Okay, so at high level, why Rescale? Well, in one sentence, because Rescale provides a complete HPC solution in the cloud for your simulation workflows. If we think about Rescale in terms of a house, it might look something like this. So Rescale would be the completed, painted, ready to move in house where you bring your family, your pets, and you're ready to go. Versus if you can, of course, build the house yourself, and you can build your own HPC system, whether that's in the cloud or on premise or somewhere else. but you have a lot of work to do. You have to get the permits, you have to buy the property, you have to hire the crew, you have to buy the materials, you have to, of course, do the building and make sure it all works after you're done. But with Rescale, we've done all that heavy lifting for you, and so you can sort of ask us to take on that risk to run your simulations for you. Let's dive a little bit deeper into that question. So why Rescale, both from a technology and a business perspective? So on the technology side, over on the left of the slide there, there's a few things to keep in mind. First and foremost, with simulation, as probably everyone is aware, there's always the need for more capacity, more models, more design iterations, because that gets us better information and better designs. So you have the ability to run a lot of different simulation design cases with flexible computing via the Rescale platform. Rescale takes all of the commercial off-the-shelf tools like ANSYS, Fluent, like you'll see today, as well as in-house or custom software applications that you might bring, and allows you to port those. We manage the applications for you. You can port them into the cloud. We tune them, we optimize them for running on the cloud computing hardware. The job management, scheduling, compilers, libraries, again, are all set up for you. You can actually configure some of those to your own requirements, as well as the operating system, the network and interconnects, and then of course the actual hardware sitting on the floor is provided to you with, as we note there, fully automated service level agreements in place to cover all of that infrastructure. Now on the business side, what are some reasons why Rescale? Well, first and foremost, the ability to rapidly deploy resources for your engineering team is of great value. Also, and hopefully you'll see this in the demo today, we really try to make it just about as simple to use as possible. So the Rescale platform was created by engineers for engineers, and really a lot of effort's been put into how do we make this as straightforward for an engineer to bring their workload to the cloud, run it, and get their results. On the costing side, you'll see that in the demo as well today. We really try to expose the information to the end users, in this case, engineering managers, IT administrators, who may want to know how much is my team spending on the cloud? How much is this project spending? And maybe even use that to forecast usage going forward into the future. And of course, maybe last, but perhaps most important, the ability to deliver your products faster to market, more robust, in shorter time is of great importance as well to anyone who's creating anything and have engineering teams working on it. So what is the Rescale platform experience? It is an automated, agile innovation environment. And there's sort of four basic pieces that we'll cover here on this slide. You'll see, of course, these all kind of work together when we dive into the demo. But at the top, there's the software piece. And as you notice, there's several different logos there. We'll focus on ANSYS today. We're partners with ANSYS and have many of their applications pre-built with multiple versions on Rescale. I think the total list is up to around 400 different applications and growing. And then the software applications, of course, are required and along with the fully integrated stack of deployment tools. We'll dive a little bit deeper into what I mean by that on the next slide. But those connect our software layer to our hardware, which we are utilizing from the public cloud providers like AWS, like Azure, like Google, and Oracle, where we can take advantage of the best and fastest and most advantageous core types that are coming available from those various cloud providers to run your specific workloads. And then over there on the right-hand side, the way to think about Rescale, at the end of the day, it's an enterprise big compute platform. It's customer-centric. So we really try to focus on how would the customer use this, both the IT customer as well as the engineering or scientist customer. And then from security and administrative point of view, are things in line and well thought out. And we'll talk about security here in a moment. So I wanted to just touch on that enterprise deployment stack for a moment. So if you were to build your own HPC system or think about maybe bigger picture, what would it take to create an HPC system? Your list would probably be something close to this. Maybe there's one or a few less, but it's going to have the application layer, licensing, support of the system, all the way through the operating system, the networking, down to the actual hardware sitting on the floor of a data center somewhere. So there's 12, maybe 13 elements you could think of that you would need and you have to connect them all up to build your HPC system. The great thing about the Rescale platform is that we have done that and transformed all of those elements, put them together for you into a software as a service enterprise platform experience. And from the standpoint of what does the platform deliver, this is a nice slide because it kind of shows how things build upon each other. So Rescale at the top there, production ready, secure, governed HPC solution. We're partnering with our cloud provider partners as shown there. And what is being delivered to you at the end of the day? Well, automation. So you have the ability to take workflows to the cloud and simplify that process. Governance and cost control and administration of the system. Support for your production environment. So our HPC team are world-class and have extensive experience with infrastructure tuning, software tuning, and optimizing that hardware and infrastructure for various different types of workloads. The infrastructure robustness itself. So it's a fair statement to say that Rescale actually hardens the public cloud for the demands of HPC. And as I'm sure a lot of people are aware, HPC is a very unique application. It's very compute core intensive. It's also very intensive on the interconnect, the disk, and the memory, which makes it very unique from that standpoint. And there's a lot of unique requirements that HPC applications need to run, and particularly in the public cloud. And then, of course, security. End-to-end solution from the time the data comes in to when it lives in the cloud and you do your cluster computing and when you take it back out if needed. And then I wanted to just touch a little bit further on security and compliance, if I could. Rescale is the world's most secure, compliant HPC platform available. We provide to you, as you see in the demo, a full administrative management and IT dashboard so you can see and control how the environment looks like and feels for the team. You have the ability to define security policy implementation tools to make sure that your IP, your intellectual property, is handled safely. And then, of course, the data is encrypted as it comes in and transfer while it's on the cloud, and if you take it back off, encrypted as well. Those certification stamps there at the bottom of the slide, a couple are worth noting. We are, ITAR compliant and FedRAMP moderate compliant on the Rescale platform. And we actually have distinct and separate environments to support those types of workloads. So feel free, if you have any additional questions there, let us know. Okay, now I wanted to touch on a few technical pieces. So again, we're answering the question, why Rescale? And on the technical side, one additional thing to keep in mind is that Rescale presents you flexibility and scalability for your engineering workflows. So let's follow the thought experiment here on the slide. So on-premise HPC, we have a certain type of architecture of our resource, and we have the ability to fill it up with jobs until it's filled, and then the jobs queue until there's additional resources. Now, if we have a bigger resource, or maybe we have less people using it, we can maybe run 4, 5, 10 jobs at once. And that saves us time because we get our results, faster than running them one after the other. With HPC in the cloud on Rescale, we're kind of over here on the right, where we actually have the ability not only to run jobs concurrently, but to use the most advantageous architecture to run that job for its specific requirements. So for instance, CFD has the requirement of needing a fast interconnect due to all the communication that the solver is doing while the solution runs, like Fluent is known for that, right? Whereas finite element analysis, like ANSYS mechanical, may not need as quick of an interconnect, but it needs a very, very fast hard disk, and it needs a lot of RAM to support all of the matrix inversion steps that happen during the solve. Electromagnetics has its own unique requirements as well. And so again, that's one of the big value propositions that the cloud brings, is the ability to choose the right core type to fit your workload, to give you the best performance, sort of raw speed, but also best cost performance. Okay, I'm going to pause for a second and see if there's any questions on what I've shown so far before we start to talk about the different use cases for the demo. Okay, looks like no. Great. All right, so let me walk you through. There's 5 different use cases I'll present to you in a live demo mode. So let's walk through those and kind of talk about them. So the first one is a batch solve with Fluent on Rescale. You have the platform access, which you'll see in a moment. And we try to make things just about as straightforward as possible and ask the engineer for their input file, the software, any licensing that's required, and then the cloud hardware to run it on. And then we're ready to submit the job. So we'll walk through that and you'll see how that works. Next, let's imagine a case where maybe we would like to actually build our mesh with a cloud computing resource, because maybe with the mesh, the data set is on the order of hundreds of gigabytes, and we'd have to transfer that across to the cloud prior to solving. And that gets inefficient. So we'd like to actually build the mesh here on Rescale. So I'll walk you through Fluent meshing. We'll take in a mesh, we'll build a volume mesh, and then we can save it to run on a batch compute cluster, just like we did in the first use case there. So we'll walk through that one. Number 3, we'll actually look at kind of the flip side. At the end of the solve, our batch cluster compute has completed with Fluent. We've saved our file to cloud storage, and now we want to interrogate the solution, look at some results, and maybe do some post-processing live and interactive on the fly. So we'll do that again with Fluent in a Rescale desktop environment. The 4th use case is that product I mentioned that's called end-to-end desktops. This is a great fit for jobs that require the user interface to be available during the entire duration from start to finish of the workflow. So think of maybe a multi-step analysis in ANSYS Workbench, or a fluid structure interaction, or maybe conjugate heat transfer where you're mapping from a CFD to a thermal, or anything along those lines. Electronics desktop sometimes also fits into this category. An end-to-end desktop on Rescale is a batch compute cluster with a virtual desktop UI attached to it. Think of it like your head node with your UI running, and you have all of the compute underneath it. There's no limits on as far as how many cores you can request for the end-to-end desktop session. And again, the key benefits there on the right. You can run your ANSYS tools in a virtual desktop that appears to you as a user as one monolithic compute cluster. And from a costing standpoint, you have hundreds of cores available at batch core rates. So we'll walk through that use case as well. And then toward the end of the demo, I'll show you the administrative portal. So we'll look at the perspective of an administrator, whether engineering or IT, and the ability to set up your team and your projects, manage job usage, billing and monitoring, and then also configure your guardrails around software, hardware, and some other settings that you can look at as well. All right, so with that, let's jump into the demo. Okay. When you log into the Rescale platform, we're going to start with a batch job setup. This is what you'll see here. There's a landing page where you can launch some example cases, but in our demo here, we're just going to do a batch job with Fluent. So we'll give this job a name. We can choose to set a project for this job. So you'll see this in the administrative point of view, where we can actually select a project to build this computing and storage usage to. And then we really just have to do 3 things. We have to provide our input, we have to choose our software and our hardware. And again, we try to make it just about as easy as possible for an engineer scientist to get up and running. So it's a matter of minutes. So let's take a look at our input. We're going to bring files in from cloud storage. We could, of course, bring them up from our on-premise. So here's our Fluent input files with our journal script. We'll add those in. And this little diagram is interactive, so I can click on software and we'll just look for Fluent. We do maintain, as I mentioned, multiple versions going back in time of full release ANSYS versions on the cloud. We'll use the newest one, 2020 R1. And then we have to specify our batch run command. Now, Rescale populates this for you with pretty much everything you need except the journal input file name. So that's pretty easy to set up. I'll just click on it, gives it a green check mark, and fills it into that field for me. Okay. Before we leave software, we then have to tell the Rescale platform what are our license options. how do we want to bring our license to the cloud? So for most of our customers that are running ANSYS tools, this is what we see that they're doing. They're using an existing license, so they might point to the server, ANSYS license server host at, port at some host name. And they're ready to go. So that server can be on-premise, and we'll talk about what that looks like a little bit later. It can also be hosted in the cloud. But either way, to the user, all you're basically doing is specifying that port number at the license server name. Now, for our demo today, we're just going to use a trial license. But in production, you would be using that existing license. Okay, and then the last piece is our hardware. This is one of my favorite parts of the Rescale platform experience because you really get to see in front of you and sort of as you interactively, the flexibility and scalability that the cloud provides. So we're going to use the Carbon core type for our demo here. As you can see in our catalog, there's quite a few different core types broken out by, of course, chipset, but also memory, interconnect, and storage. Carbon is a great CFD core type for a lot of reasons. As you notice, it has 100 gig InfiniBand interconnect. It has plenty of RAM per core, as well as plenty of storage. So it makes it a great all-around CFD core type. We're going to run it with 132, but again, this is where the scalability and flexibility comes in. If you needed to run or could run this job, and it's scaled up to 900 cores perhaps, or over 1,000, and you get your results before coffee break in the morning rather than by the end of the day, that is possible to do with cloud computing on Rescale. Now our exhaust model here probably won't scale up that high, so we'll just stick with 132 for our little example. There is an optional fourth step here as well for post-processing. So if you have scripts that extract information from the data set after the fact, those could be created and uploaded through that step. But it's not required to run the job. So let's go ahead and submit this job. When we submit the job, a couple things start to happen. So the Rescale platform gives our job a unique ID, kind of a metadata identifier, and then it does some sanity checks. So it goes through and looks at our input files, our license settings, our software versions, and it makes sure everything looks good. So that's the validating input. It usually takes a couple of seconds. Then it moves to the startup of the cluster. Now at this phase, we are actually going out to the public cloud infrastructure provider, and we're asking for those compute cores of Carbon to start up this job. Once we obtain those cores, we go about the entire stand-up process. So we're installing operating system, we're installing the software, we're installing any drivers, middleware, and so on. Everything that's needed to stand up that cluster and run it gets taken care of in that startup phase. Then we get to the running of the job, and that's where we're actually starting up Fluent, we're seeing it run, and where the billing actually begins as well. So this will take a couple minutes, probably around 2 to 5 minutes to fire up. Let's take a look at the same job. I've actually got it running because there's a couple more things I wanted to show you guys before we move to the next demo. Okay, here is this batch job that's already running. And when the job starts, there is a feature called live tailing that appears in between the Gantt chart view and sort of what's below it. This is one of my favorite parts of the Rescale platform because it allows you to see kind of live updates of your simulation while it's solving. So it's named after the Linux tail command, if you may be familiar with that. And what it allows you to do is see the top level solver output from the solve as it's running. And it also allows you to see any additional files that you may have generated during the solve. So in my case, I set up some output image files so I could take a look, how does the solution for the temperature progress through the solve. I also have a way to, and this is straightforward to set up in Fluent. I just have picked an output of the residuals from the calculation to also show me where things have progressed up to this point. Okay, so let me pause here and see if any questions have come in before I jump to the next piece. Oh, okay, looks good. All right, let's jump over to the pre-processing demo then. Okay, now this demo, what I want to walk you through is the Rescale desktops, and more particularly, how to do meshing with Fluent in a Rescale desktop. So these are a couple desktops that are already started. We can, of course, build a new one if we like. It's pretty straightforward to do. Different hardware choices, just like in the batch clusters. The default is this one here at the top, the hardware accelerated, which I highly recommend. And then we can select our software, our license, and then attach a job to it. And then once we're ready, we can go ahead and launch this desktop. Now, we already have one launched. Again, it'll take probably around 5 minutes to start it up. So in the interest of our demo, I've already started one up for us. Let's take a look at that. So if we had clicked on connect to our session, this is what we will see. Is our Windows desktop with our ANSYS tools attached to it. Now, I've taken the liberty to start up a Fluent session, but if we wanted to start up a new one, we can just double click on our shortcuts here and walk through our Fluent launcher with as many processes as we need and our case and data files or our meshing as the case may be. So I've gone ahead and started this up and read in this model. So this is a surface mesh of our exhaust system. We could also start from geometry, just like we could if we were working locally on our workstation. And of course, our different workflows within Fluent meshing are possible: watertight geometry, fault tolerant. All of these are there just as if we were sitting in front of the terminal in person. But for our use case here, we're just going to do a simple volume mesh generation for our demo. And just to make sure, we'll take a look inside the model, make sure we don't have any stray volume elements that may have not been removed. So let's zoom in a bit over here on one of the manifolds. There we go. Yep, so just surface elements. We can move the model around, kind of see how things behave. Pretty straightforward. The other thing I'll draw your attention to is the low latency. So we're using some pretty nice back-end technology to keep things nice and fast. So you can spin the model around and it moves and feels very much like you're there locally in front of it. So let's go ahead and build this volume mesh. All right, there's our object. We just have one big volume. We're going to fill it with tetrahedrals. We've got our growth rates, and we're going to merge all the cell zones together at the end. All right, so Fluent meshing is going to go and do its magic. It'll probably take 2 to 3 minutes to build this volume mesh. And again, while that crunches, I've actually got the completed version that we can take a look at here. So here's all of our cell zones now. Those have all been created. And here's our final product of the exhaust system. And again, let's take a look. Let's sort of clip things so we can see what's going on the inside. We'll zoom in a bit as well, and then let's see how our volume mesh sort of shook out. So there's our surface mesh. We just need to turn on the volume elements. And there we go. Now we did just tetrahedrals. We kind of did a first pass mesh at this just to see how the quality and how the sizing turned out. We could, of course, go back and redo and refine the mesh as well. All right, so that brings me to use case number 2. There's, of course, a lot more we could do. We could go through the full model setup with Fluent in solver mode as well. But I'm going to pause here, see if there's any questions. Doesn't look like we have any questions yet. And let's go ahead and move to our next piece of the demo. So use case number 3, which is pre-processing. Sorry, post-processing. So now we've completed our batch solve. And we have our results attached to our desktop. Same process as before. You could even use the same desktop, which is what I've done. And I've brought in and attached my data set, my results files, to this session as well to do some post-processing on that. So let's pull up our completed product here. All right, there's our fully solved model, so not just the mesh, but the data as well. We can take a look at the residuals if we need to. We can also look at contour plots. So let's plot a contour. We're going to look at static pressure through the system. We can move the model around again and sort of make sure we get the view adjusted how we like it. Looks pretty reasonable. Then, of course, we could do other things as well, like maybe we want to set up a scene that incorporates a couple of different types of results, some path lines perhaps, as well as a contour. So we can draw our scene as well. And of course, various other types of post-processing like animations and reports. Just again, like Fluent, it's a Fluent session running on a virtual desktop. So you have the ability to do whatever you would normally do with an interactive post-processing session using Fluent. All right, so let me move to the next step here. So that is use case number 3. That's our post-processing. So now we've sort of done from beginning to end, right? We've done our batch solve. We said, well, wait, what if I want to mesh on the cloud? Okay, we did the meshing. And then, oh, wait, I need to do some interactive post-processing, and we've done that now as well. So let's go to the next piece of our demo, use case number 4. Again, one thing to note, we're using in-browser VDI. We can full screen that, but we are coming back to our browser tab. The next piece here, we are going to move over to an end-to-end desktops example. So I mentioned that is a great fit for workloads like fluid structure interaction with Workbench. So let's go ahead and walk through that setup, and then I'll show you kind of what it looks like when you do that. So same thing as before, it's a batch job. So we set it up in the same way. We prescribe our input, our software, and our hardware. There's one more thing we have to do here. Under job type, we have to make sure and set this to end-to-end desktop. Now, Rescale gives us a message here and says, hey, an end-to-end desktop is a batch cluster, but it's not going to shut down when it's done. So you have to shut it down when you're ready for it to be finished. So you just have to click on yes, and you're good to go. So now, same thing, we can add in our files from cloud storage. We just need our case and data file since we're just going to run the GUI. We pick our software. Same thing with licensing. You can point to existing license on premise. And then we have to select our hardware type, just like we did for our batch cluster. Emerald is a great core type for the end-to-end desktops. And again, we can bump this up as high as we need it based on the size of the model. And once we are good to go here, maybe we don't need 300, but we can use 180. We'll click submit. It looks just like a batch job when it starts up. The only difference is there is this connect to interactive session button that's available to us. It basically, once it's ready, so the batch job will stand up. And then once that's completed, the cluster is started up, this button will activate, and then we can click it and look at our end-to-end desktop environment. So if we were to click that, this is what we would see. So this is a Linux desktop environment where we have our ANSYS tools installed. So Workbench, Electronics Desktop, Fluent, CFX, and our associated tools underneath each of those. We're going to run Fluent. And we are going to look at how our solve is progressing with Fluent in the cloud. So let's reconnect to it here. So here's our end-to-end session that's running, and we're just going to connect to our interactive session. Okay, so I might need to come back to that one. Once we connect to our end-to-end session, we are going to see the Linux environment, and we'll see our Fluent UI. where we can set up our job, we can run it, we can interact with it, pause the job, do whatever we need to do with our live Fluent UI. All right, let's go to the use case number 5, which is the administrative point of view in the administrative portal. All right. We log into the Rescale platform with administrative privileges. This is our landing page. So in my case, I've created a little test company. If I were to be in the automotive business, maybe my company would be called Smith & Camp Automotive. So this is just a representative data set, and we're looking at an economics perspective, sort of a project budget point of view. We've aggregated the data together to look at with these various projects, how many jobs have been run, what software, what compute, and how much of the budget has been consumed by the team for that project. And we're showing here, we're breaking out compute cost kind of as its own separate data set, and of course can be is added into the total. The other point of view here is more on the utilization side. So that's the costing side. How much is the team actually using from a consumption standpoint? So here at the top is a core utilization chart of various different days and core hours consumed per day by our entire team. We can also look at sort of a running active core count. Again, these workloads are going to bump up, so usage will bump up, of course, according to project deadlines like critical design review and so on. But there's a few different ways to look at that. And of course, we can set the window differently also. We again sort of pull out and extract hardware usage by core types. So we see, maybe our team's using Carbon and Yttrium are the two heavy hitters. What are our charges for those? And then things like storage and transfer. Who's storing the most data on the cloud? Who's transferring the most data off of the cloud? And questions like this. And one thing I wanted to mention, this is again an aggregate of the raw metadata that you have access to as an administrator of your Rescale environment. So you'll be able to see every single job, along with who ran it, what the cost was, what core type, and so on, all of the metadata available to you in a spreadsheet for download at any time. So you can run your own artificial intelligence or pivot tables or scripts or whatever it is you would like to do to extract those data. You have access to it. And we're just showing you one perspective of how to do that with these dashboards. Moving on from here on the platform side, so we talked about kind of earlier, what does the Rescale environment offer to the administrator? So from a platform point of view, there's a couple different things, and you can think of these as different types of guardrails to guide the team how you want them to use Rescale. So for instance, you can require all jobs to be assigned to a project. That can be pretty useful for billing purposes. You might, for instance, set your job or have your team only have a maximum wall time of a certain number. Maybe you don't want them able to run a job for a week. Maybe you only want them to able to run for a day. And then you can set settings around data age as well. Maybe after a week or a month, you're going to scrub the data from the storage, and so you need people to move things off or delete it. And there's other things as well. You have, of course, access to the running jobs at any time for your entire team. You'll see that list grow over time. And then you can set restrictions around hardware. Maybe you want your team only accessing, maybe the CFD group only needs to run the CFD core types and see them in their list, in their catalog. And maybe you want to restrict software, so the CFD users only see Fluent and CFX. Things like this. There's also limits you can set on transfer and storage as well. Then moving on to the team side, here's where you would configure new users, maybe who has administrative level access as well. And then additional setup for groups and projects. So maybe there's, in my automotive company, I have my powertrain group and my NVH group, and these would have certain users and budgets tied to them. Projects are similar from the standpoint that I can have even a collaborating group tied to my project, a budget that goes along with it, and then all of the jobs that have been run against that project budget are visible here as well. I mentioned the costing side briefly. Let's touch on that. So here is sort of a high-level summary of all of the different costs and charges that your team is seeing in this window of time. So June 2020, these are the various different hardware, storage, transfer charges that your team's accumulated. You can at any time download the CSV file, which is, as I mentioned, the full set of metadata for every single job in that time frame you requested. Additionally, under costing, you have your budgets that you can configure, any invoices that you that have been sent to you from Rescale, or purchase orders or deposits that you've made on your account on the Rescale platform will show up here also. All right, so that brings me to kind of what I wanted to focus upon for the administrative side. There's a couple things, last but not least, the licensing. How do I bring my licenses to the cloud on Rescale? So that's kind of our last use case, and that's also under here, the admin portal. So let me talk about that briefly. Security settings are here as well. There's quite a bit available here, like audit logs and transfer logs. We highly recommend multi-factor authentication, and various different configurations are possible for passwords and so on. But for licensing, this is where the administrator for your account would set up that connection to your licenses. This is using a technique called license proxy. And here we are essentially just setting up a secure connection to your licenses, either hosted on-premise or hosted by this license proxy server. And you can then connect to that from your on-premise. So either way, there's a secure connection involved. And that can be through VPN, it can be through encrypted SSH tunnel. But there's a few things you have to specify, like allowed IP or site ranges, host names, and there's detailed documentation on how to do all this. Pretty straightforward. But this is primarily how customers are bringing their licenses to the cloud with Rescale. Once this is set up, it's pretty straightforward. The batch clusters use a license, and away you go. Okay. With that, let's go back to our slides for a moment. From a demo point of view, that's what I had planned to show today. Again, if questions come up, we can always go back to the platform and address those. So let's present our slides again. And last but certainly not the least, I wanted to show you some performance for this exhaust case. So credit goes here to a couple of my teammates, Madhu and Bernardo, who did this benchmarking. This is the 33 million exhaust model that you saw in all of the demos in Fluent today. And we're looking at performance versus number of cores. Think of this like a speed up graph. The higher the number, the better performance we get. And we're comparing and contrasting different core types on the Rescale platform. So Carbon, Luna, Serpentine, and Amber are the colors that you see there. This is a valuable exercise because we're looking at, of course, raw performance in this perspective, but we also, this is an exercise we go through with most of our customers as they walk through their journey to the cloud computing with Rescale, because it's really, really valuable to know, like we mentioned earlier, what's the best core type for your workload. And how do we define best? Obviously, we want fast, but we also want affordable. So there's some cost optimization as well as performance optimization that we look at and find, is there a trade-off between those? If so, where is it? And what's the best case scenario for you and your team? And so that's partially what this represents here. This is raw performance, so we're not showing costing necessarily on this graph. But what I wanted to draw your attention to is, the performance between core types. So the yellow line is the Serpentine. The numbers above are the actual iterations per day at that core count. So, around 370 cores and maybe around a little over 700 cores, we definitely see a nice increase in speed up, the ability to solve more iterations in a single day. Same with Carbon. That one was run even up over 1,000 cores. Same with Amber V2. Pretty nice scalability. Luna starts to show a little bit of a drop off with higher core counts. And again, this is the kind of thing that we're looking for. We want to know, with this core type, do we see lesser performance as we increase the core counts? And if so, why would that be the case? And so on. So this is a valuable exercise that we go through a lot, and we actually have a significant database of benchmarking results from Fluent and other softwares as well that we draw on our experience to come to these conclusions. So that brings me to the end of what I prepared today. I'll pause here and see if you have any questions. Thanks for your attention.
Thank you, Clinton. We'll just wait for a few seconds here. If anybody does have a question, again, feel free to write it in that question window, and we will address those as we see them. And as we're waiting for questions, just want to make you aware or give you a reminder that we will have another webinar on June 17th, and you're welcome to join us for that one as well. Still not seeing any questions here, so if you don't have any questions, feel free to join us next time. We're glad to be with you today, and everybody stay safe out there and have a good one.